So today is Wednesday, October 21st, 2020. We'll be introducing finding solutions to linear functions. All right. Some of you may have already seen this in middle school, and that's perfectly okay. Some of you may not have seen it before, and that's perfectly okay. All right. So again, let's get started. So the first thing is, what is a solution? When we look at an equation, we look at a function, what does it mean to be a solution? Right. A solution to an equation is a value that makes the equation true. All right. That's what we would consider a solution to any equation, right? It needs to be true. The value needs to work. Okay. So if we consider the equation or the function, right, y equals x minus 2. It's a linear function. If we graphed it, we would get a line. Okay. The value of y depends on the value of x. Right? Y, we can't figure out what y is unless we know what the value of x is. Right? When x equals 2, right, we would see that y would equal 0. That would be the output of this equation. So visually, when x equals 2, the variable x gets replaced with the number 2 in the function, and we get 2 minus 2 equals 0, which equals y. Right? When we have this function, y is representing the solutions. Right? It's well, not the solutions, it's representing the outcome of certain x values being put into the equation. In this case, when x equals 2, y equals 0. For this function, the only value of x that will result in y equals 0 is 2. There's no other number I could put in this equation and get 0 as the outcome. I could get close, I could use decimals and be close to 0, but I will never get equal to 0 with any other value besides 2. So that means that if I were asked to find the solution for the equation, x minus 2 equals 0, the only value for x that results in a true outcome is x equals 2. So in this case, x equaling 2 is the solution for the equation x minus 2 equals 0. There's only the one solution. There's no other possibility. All right, so here's the question. What value of x makes this equation true? What value can I replace x with to make this a true equation? All right, we got a response here in our chat here. Jocelyn says it is 7. All right. So yeah, Ariana agrees that it's 7. Okay. And we can see that in fact, if we put 7 where x is, we subtract 2, we will get 5. All right. So we see that the solution to this equation is x equals 7. Right, and this would be the solution. Yes, so, do you have a question? No. So, when we're looking at this, right, obviously this is a more basic example, right? We don't have anything besides subtraction going on. But we're going to use this as the basic example so we can kind of see what's going on, all right? Where can we see the solution to that same equation on a table or a graph? Right, if we're looking at the table here, where do we see the solution for x minus 2 equals 5? Consider the table first. Again, Jocelyn says the second to last row. Can you expand on that? What do you see in the second to last row here? Right, that lets you believe that this is where the solution is in the table. Or anyone else can jump in as well. Why do we believe that our solution can be seen in that second to last row? Sure. So what I'm asking is, Jocelyn is saying the second to last row here is where we can see the solution to x minus 2 equals 5 on the table. How do we know? What are you seeing that makes you believe that that is where the solution is on the table? Okay, yeah. The value of x is 7, right, which we already know is the solution. All right, and the table is labeled x on top where the 7 is, yeah. What about the y value, so to say, the right-hand side of the table? Is that the y value? Yeah, x minus 2 equals 5, right? This is the y value we were looking for, was 5, right? And this is the value of y. And so on our table, if we just kind of look down our table until we hit 5, that goes along with 7. So this shows the solution that we were looking for. It's found the value we wanted from our equation. All right. Now, if we're looking at a graph, right, how do we use the graph to find the solution? This is the graph for the line, y equals x minus 2. That's what this green line down our graph is. So if I'm just looking at the graph here, and I want to know, okay, where does x minus 2, where does this line equal 5? What do I look for? Which axis do I look at first, the x-axis or the y-axis? Okay, Jocelyn's suggesting the y-axis is where we want to look first. Why do I want to look at the y-axis first? Okay, so we have Jocelyn saying, so you know your starting point and to see where the y-intercept is from Eileen. So consider what we're being asked when we're equals 5. I need to find, right, I need to find this. I need to find the value for this. I already know the y value. Right? I know y equals 5. I want to know where along this line does y equal 5. So I'm going to start at y. Look at 5. And we're just going to follow this along until it hits the line. Because at this point on my line, y equals 5. And so then we just follow it down. To see what x value goes along with it. This point has the coordinates of 5, 7, sorry, and backwards, 7, 5, I apologize. All right. So that's how we can use the graph here. We start with y because I was given a y value. Right? So we find 5 on y, follow it over, hit my line, follow it down to see what x value goes along with it. Right? I could do the same, right? If I wanted to know, okay, where does the line equal 0? Right? We start at 0, follow it over, right? So we get 2. So we can use the graph, right, to find solutions, to find what value of x goes along with a given value of y. Or I could go the opposite way. I could say, okay, if I put in a value for x, what's the value of y that I'll get out when I have the graph? What questions do you have? What can I clarify? So, in a nutshell, the solution to an equation is the value or values that make that equation true. There will be circumstances, not with lines, but with other types of functions and equations, where there is more than one solution. We'll get into that later this year. But for now, with linear functions and linear equations, there will only be one solution. Right? We can see that on our table and on our graph. There's only one possible x value to go with this y value. There are no others. Right? We can use kind of just basic reasoning to say, okay, well, 7 minus 2 equals 5. We can look at the table to find our solution. We can look at the graph to find our solution. So we can see the solutions in the different representations, right? And that's important because that kind of piggybacks off of what we did previously for this unit, right? Dealing with the different representations of our linear functions. Here we go. We will start. All right, so again, this is our Wednesday, October 21st, 2020, a Pear Deck. We're going to be finding solutions to linear functions. There are 1, 2, 3, 4 questions on this Pear Deck. So let's get started. First one, what value of x makes this equation true? For this, use some reasoning. You might need to do some guess and check. That's okay. But what value of x makes this equation true? We have x plus 3 equals 1. Alrighty. So, in this case, the correct answer, or the value of x that makes this equation true, is -2. Okay, -2 plus 3 will equal 1. All right. Negative 2 is the only value that will work for x. All right. Are there any questions about this one? Anything I can clarify? Okay. Next. We have this graph here. You're going to use the graph to find the solution to x minus 2 equals 10. And ask you to use the graph. If you do not need to use the graph and you know what the solution is, that's fine as well. But the graph should be a tool. And then again, make sure you check your work. Once you have a number that you believe works, put it in place for x, replace x with that value, and do the math. If you do not get 10 as the result, then there's an error. You need to try again. Okay, so again, please make sure you're attempting these questions. All right, so what you can do is on the y-axis, find 10. Right? 10 is the value that I want y to be equal to. So if I go to 10 on the y-axis, and then I trace over to the right until I hit the line, right? I'll hit that green line. And from that point, I just trace directly down until I hit the x-axis. That value I hit when I hit the x-axis should be the value of x that works. So again, find 10 on the y-axis, trace over to the right until you hit the line, down until you hit the x-axis. Whatever value is right there on the x-axis from you trace down should be the value of x that makes the equation true. Right? Okay. So the correct value of x, this equation, is 12. So we replace x with 12, we get 12 minus 2. 12 minus 2 is, in fact, equal to 10. So we're looking for 12. And always check your work. If you have a value you believe works, put it in the equation. See if you get the required y value out as your result. All right, this one's a little more interesting, a little more complicated. I want to know, between these two lines, what value of x will the two lines be equal? So at what value of x are the two lines worth the same amount on y? So for this problem, the value of x, where the two lines cross, will be at 2, x equals 2. Solution to where the lines are equal is x equals 2. All right. Questions do you guys have? What can I clarify? I know this one was a little bit harder. question. We're going to use the table on this one. What is the y-intercept for the linear function y equals x minus 2? Please type your answer as a coordinate. Right. So you use the parentheses and put your x and y values within the parentheses. This goes back to what we have been doing in the previous weeks. I'm asking for the y-intercept. In this case, the coordinates for the y-intercept would be parentheses 0, comma, -2. And I'll type it in the chat over here as well. Right. Coordinates need to be written with parentheses around the values of the x and the y value. So the answer needs to be within parentheses. 0, comma 2, the coordinates of the y-intercept. The y-intercept is always the value where x equals 0. Okay.